Okay, and we go for the second presentation, and this is about LangChain. Some of you already listened to it, but so LangChain framework is a framework to work with large language models, right? It can work with multiple LLMs. It's very flexible. You can create chains or sequences of commands to run. It can keep information about previous messages, so it has memory. Please mute yourself. Please mute yourself. It has tools for debugging, testing, evaluating, monitoring applications. It provides prompt templates, mechanism, which is, well, you have to use it. It's so convenient. Question answering, or explain like I'm five, summarization, and so on. So many convenient templates which you can use, and you can build agents, and they already have prepared applications which you can just take out of the box and a little bit customize and use. So it was open sourced a year ago by Harrison Chase. Here's his picture. There are a lot of tutorials. Here are some links related to it, quick start, standard documentation. People mostly work with it using Python, although it also supports JavaScript. And I highly recommend to look at courses at deeplearning.ai. So it's deeplearning.ai/short courses. It's a very good courses. And here I just made a picture. There are eight courses right now, and several of them are dealing with, you see, it's ChatGPT prompt engineering, building system with ChatGPT API. This is LangChain, this is LangChain, and semantic search, whatever. So there are eight courses total. So I highly recommend them. Now, somebody asked me why LangChain, why not Llama Index? So I decided to look into this, and this is the list of 14 top most popular frameworks. And LangChain is by far the most popular and flexible and used everywhere. The second in popularity is Llama Index. Well, Llama means Facebook, right? It's also good, but I guess more specialized and less flexible. There are Hugging Face transformers. Again, this is GitHub to work with transformers, and then many others. And I tried to color code what they're doing. And you see chatbots, chatbot. Oh, this is strange. This is graph neural networks, AI agents, federal learning apps, voice assistants, neural language understanding, conversational API, prompts, conversational API. So some of them are quite specialized. A lot of it is about chatbox. LangChain is really flexible. Whatever you want chatbox, you can do chatbox. But if you want something else, you can do it. So that's why we selected LangChain. Uh, Add natural language interface. Create an agent. So people are now creating agents to do something, and then they do first step, and then the agent may think what I should do next, and so on. So agents become quite intelligent. So this is kind of the plan how you can do it in pieces of syntax, how you can do it in LangChain. The point is it's very easy to do. So this is example how to work with LangChain, vector database, and large language model. He is mostly explaining that, well, when you're creating a table, in this case, it's PostgreSQL with pgvector extension, you can create a column with the type vector, and then from Python, this is from Python, you can create extension if not exist vector. And well, for this, you need the extension to be installed on your computer. Um, then you can execute, you can, in this row embedding, you see this is placeholders, $1, $2, $3, and you put there some integers, some content, and then you put here, you put an array. And that's how it works. So you can put embedding arrays inside your database, and then you can query, you can do similarity search, and you see it's well regular SQL, and it may be a combination of regular SQL statements and the ones related to similarity search. So, and they're all together in one statement. Embedding models. Well, I spoke about embedding models last week. So one embedding model in particular, it's called text embedding ADA002. This is coming from OpenAI, and that's what most people are using because, well, it's quite powerful, it's good, it's not the first version, it's improved, it's very low cost, so you're paying 1 cent for about 150 pages of text. And yeah, so it's a good thing. But when you're using it, you'll be sending all your data, and if you have terabytes of data, all like terabytes of data to OpenAI via internet, and then they have the right to use it to train their model. So like this, what product people need to okay, this is article which is called "What Product People Need to Know About LangChain," and these are some main components of LangChain framework. So first of all, you can make chains, like step-by-step execution of something. You can also program tree of thought approach if you want to. You can generate action plan, reasoning and action, thought and action, understanding the why behind the action. It's about the model taking a moment to contemplate, to reason, and then to act. It's called react. Self-ask. Prompting encourages the model to be more productive and inquisitive internally, ask itself questions. Prompt chaining, mimetic proxy, simulate well-known figures or situations to shape its responses. So pretend that you are this kind of person, how would you do it? Self-consistency, inception, first person instruction. So add the start of the model response into the prompt. So you initiate the response and then ask it to continue. Mem prompt, keep memory history. So these are all standard tools which you have inside the LangChain framework. So these are some links. You can create schema, and there are components, model, prompt, indexes, memory, chains, and there are some pre-built for you chains which you can use. Agents, action agents, plan and execute agents. This article I liked because this is a very common task. You have your own documents of different format. It may be text, Word, PDF, whatever. And you want to build a cognitive search so you can ask questions about your data. And the standard way to do it, you first convert it to text and then split it into chunks and then convert chunks into vectors using embedding model. And then these vectors go into a vector database. So this is one. And then when you ask the question, so now you have a text query, it goes through the same embedding model, you get the vector, and then you compare this vector to the vectors you have in your vector space in the database. You select using similarity search the close matches, you add them to your prompt, whatever person asks, you ask to the prompt, and then you send it to large language model and it responds. And so this is very common architecture, and actually we did it like yesterday on our study group. We did exactly that, and it works very well and very simple. Okay, this is it for today, and I will stop recording. I will try to stop recording.